Alright, so this is that question I just mentioned. I just read the question again actually. It doesn't ask you to find the nth term, does it? Well, maybe we'll just have a go, okay? And see how we get on. So the previous example was how to find the nth term for quadratic. This is that question. It actually asks you to work out the next 3 terms are using the difference method, okay? I'm sure you can work out what they are. But let's just have a go at working out what the nth term is, okay? So the first differences would be 2. If they're positive, I'll just write 2, okay? So you can do the same if you want. So that's 5, and then that's going to be 8, that's going to be 11, that's going to be 14. So they're not common, are they? So what we'll do is we'll look at the second differences and see if there's anything going on. So 3, 3, 3, 3, yes, okay. In terms of the actual question it does ask you, obviously the pattern will be 2, 5, 8, 11, 14, 17, so do 41 plus 17 to get that number, okay. And then it will be 20, and then do that number plus 20, and so on, okay. But what I've asked you to do is try and work out the nth term of this. So hopefully you're aware that means we start off with 3 over 2n squared. Remember I said the method is whatever that second difference is, you divide by 2, you halve it. So you can either write 1.5 if you wish, or 3 over 2n squared. Okay. And then what is 3 over 2n squared? What is 1.5 times n squared? So let's just write out the square numbers first. 1, 4, 9, 16, 25, 1, 2, 3, 4, 5, 6, 36. And we'll do 1.5 times each of those. Okay. So what is 1.5 times each of those? You're probably going to be happy with decimals, aren't you? Alright, fine. Just for you, decimals. Okay. Fractions are better. Okay. So 1.5 times 1 is 1.5. 1.5 times 4 is 6. 1.5 times 9 is 13.5. 16 times 1.5 is 24. 25 times 1.5 is 37.5, and 36 times 1.5 is going to be 54. You're probably thinking, this is going to be tricky. Yeah, it is. Stop moaning, always give me tricky work, doesn't it? That's what makes maths fun after all. Okay, let's just hang it there. Right, so that's, okay. That's 1.5n squared. Alright, what's the rest of the sequence? Remember we did that last time? We looked at what we do with these numbers to get those numbers. So 1.5 subtract 0.5. If you want 6 subtract 3, that's another subtraction one, isn't it? 13.5 subtract 5.5. 24 subtract 8. 37.5 subtract 10.5, 54 subtract 7. Idiot. Sorry, no. Those numbers, I was like, no. Let's try it again. 54 subtract 13. Where did 7 come from? I was watching James Bond last night. 007 is obviously in my head. Okay. Anyway, there we go. It's true. I was watching James Bond. In anticipation of the new film, No Time to Die. That's one of the most annoying things. This coronavirus has meant I can't go to cinema to see that James Bond film. Really annoying. I was looking forward to that as well. Anyway, get that off my chest. Let's find the nth term for this then. So what's going on? So we're going to add on, we're going to subtract 2.5, aren't we? Here we're going to subtract 2.5. We're going to subtract 2.5, subtract 2.5, subtract 2.5. By the way, if any of those numbers are not negative 2.5, done it wrong somewhere. Okay, like we would have done had that been 7. And so that means it's the negative 2.5 times table, so negative 2.5n. Okay, let's write down what that is. So negative 2.5 times table is negative 2.5, negative 5, negative 7.5, negative 10, negative 12.5, and so on. How do we get to these numbers here? I want to do negative 2.5 plus 2, negative 5 plus 2, I'm checking all of them work, negative that plus 2, negative that plus 2, negative that plus 2, all seems good. Whew. So that means our final answer must be 1.5 n squared, subtract 2.5 n plus 2. Yippee. Should we check it works? 1, 2, 3, 4, 5. Put the sixth one into it. I've chosen an even number to make it easier. Okay, so 6 squared is 36 times 1.5, 18 plus 36, 54. Let's write it down. Subtract 2.5 times n, so 6 times 2.5 is going to be 15. So subtract 15 plus 2, 54, subtract 15, 39 plus 2 is 41. Look up. Yes. Okay, yeah, that's our formula for the nth term. Okay. Yeah, okay. Now, I think that's all you need for quadratic sequences. Okay, I had a quick flick through the book in the break in between recording. Okay, and they don't really talk about quadratic sequences that much. Okay, however, in some of the past paper exams, they've crept in occasionally. Okay, and on that slightly off chance that it comes up, at least you've seen what the method is. Okay, don't dwell on it, do not worry, it is something difficult to come to terms with. Okay, we don't really actually do that sort of stuff in A level either. We do things that are still hard, yes, but different. Okay, but we don't generally do quadratic sequences in A level. Okay, so don't panic. Oh, touching face, it's not a good idea, is it? You know, don't touch faces. Yeah. So anyway, that's that. Okay. Hope you enjoyed it. Hope you found it challenging. Okay. But I'd rather you see quadratics than not.